Alright, so in this video lesson we are going to learn how we can factor a quadratic expression. So before we get further, allow me to give some decent enough insight, understanding about what a quadratic expression is. Alright, so we have seen something like this, a 2x squared plus a 3x minus 1. So we have variables, we got three terms for this polynomial. And the first term, there's always one term with the variable here is raised to the highest power, the square power. Okay, it's a square right here. Okay, so there's a square term, and then there's a linear term. This is power 1 right here. We don't see a power written down, that means it's power 1. So there's a square term, there's a linear term, power 1 term, and then there's a constant. This is the constants. Okay, so and another detail I would like to mention is that with this quadratic expression right here, so quad here means it's power 2. It's a square, making it a quadratic. So a quadratic has to have a square term in it. Okay, a square term on the variable, and these are the coefficients, the 2, the 3, okay, the 2 here, and the 3 here, these are the coefficients, and including this, the constant here, these are the coefficients. Okay, and so another detail to look at this particular expression that I brought up right here, this quadratic expression that I brought up right here, is that it's only involving one variable. Okay, so the first major class of a quadratic expression is a one variable quadratic. So a one variable quadratic here is simply in the form of a some coefficient a times with your variable being square plus with some other coefficient times with your variable being to the first power and plus with a constant term. And so in this case of the quadratic that I brought up right here, the a is playing the two coefficient here is playing in place of the coefficient a. The plus 3 is playing in the place of that coefficient b in our general form of a one variable quadratic expression. And then the minus 1 right here is that constant c right here. Okay, so in this particular one, you can see a equals 2, b equals 3, and c equals negative 1. Okay, so a more advanced form of a quadratic expression, the one I brought up here, is a one variable quadratic expression. We will sometimes work with a two variable quadratic. And so just in that structure right there, the two variable quadratic goes like this. So we have an a x squared term, and then there's a middle term, but now we start seeing, so there's the bx term just like the one variable quadratic, but now there's the secondary variable that's involved right here. So there's a bxy, and then plus with the cy squared term. Okay, so this is truly this is the way how I see it, a two variable quadratic expression. So one quick example could be, it can be a 3x squared plus 4xy and then plus y squared. Okay, so it got two variables involved. That's why it's called the two variable quadratic. Now there has to be one specific square term on one variable and another specific square term on the other variable, and then there's a linear term where both variables involved having power 1. And so this is one example right here illustrating. And so in this case, in this two variable quadratic right here, I'm looking at a here is being 3, b here is being 4, and c here is being 1. It really means a 1 times the y squared. And then another way to another way to realize, to be aware about a two variable quadratic is that usually we don't write a constant term. Actually, usually we don't write a constant term, but here's the way how it goes right here. The ax squared here, there's no y in the first term. So there has to be one unique term only for one variable being squared. and then there's another unique term that goes with the other variable being square. So if we're looking at the pattern of the power, it goes x squared and then x to the first power, and then in that last term right here, there's no x, power 0 on the x. And then the y variable goes the other way opposite. At the last term right here, it's y squared, and then the middle term here goes y to the first power, so the power on the y reduces down as we go to the left-hand side. So y squared go to y to the first power, and going to no y, meaning y to the 0 power. Okay, so the x variable, one of the variable goes decreasingly from the left to the right, and then the other power, the power on the other variable goes decreasingly from the right to the left. And that's how you can recognize a two-variable quadratic. All right. All right, so now after having some insight understanding of what a quadratic expression is, one variable and two variable, we're going to start learning our technique. So everything we've learned in this particular video lesson is a skill, but the skill to factor specifically quadratic expression. So the skill we learn here is for specifically targeting at quadratic expressions. Okay, and so the content we've learned here are more oriented towards just on the quadratic expression. Yeah. All right. So let's start out with the simplest case. All right. So the first case, the first problem I would like to introduce is we want to learn the method of how we can factor a one variable quadratic expression with a equals 1. So after I have introduced earlier in this lesson about what a quadratic expression is, so I, among many other instructors and including anyone learning from this lesson, eventually you're gonna get into the habit of a here represents in a context of a quadratic, a means the leading coefficient. Okay, so when I'm saying a one variable quadratic expression with a equals 1, it means we're looking specifically at the quadratic expression where the leading coefficient equals 1. All right, and so allow me to bring in an example, and then directly through that example, everyone is going to learn the methods. I will spell out loud what we do step by step. Okay, and then you will learn through the example, and you will also understand more clearly what it means by being a one variable quadratic with the leading coefficient equals 1. Okay, so all right, so here we are at what I call that example 1, but it introduces for us a problem where we are instructed to factor this quadratic expression. So this problem, this quadratic expression here is regarded as a one variable. Okay, so clearly there's one variable involved, only the x being the variable. There's no y, there's no u, there's no n additionally involved here. It's just one variable involved. That's why it's a one variable quadratic. Now, the leading coefficient, or the coefficient meaning the coefficient that attached that goes with the square term, is 1. So here the way how I'm reading it, x squared minus 7x plus 12, x squared here means 1 times x squared, and that's why it's under this category where we're looking at the coefficient a equals 1, the leading coefficient being 1. Okay, so we will learn specifically how we can factor a quadratic expression of this kind here. Again, one variable quadratic with leading coefficient 1. Okay, so now when we get into this, the first step, as easy as it can be, well, and the final product has to be whatever expression as a final product right there, as a final factor form right there, will be just simply equal to the original expression. It's just a different way of writing it, so I put equal sign here. So now the first step here, I'll just simply put in 2 pairs of parentheses. Just get for yourself ready with 2 pairs of parentheses. I keep telling my in-class, in-person students, nothing in the world is easier than producing 2 pairs of parentheses. Okay, so that's the first step. Okay, and the next thing, you can call it the second step. I'm going to put an x here for the first pair of parentheses and another x in the next pair of parentheses. Okay, so nothing is easier than doing 2 pairs of parentheses and put an x here and put an x there. So each x goes into one pair leading in the parentheses. Okay, so there's an x here leading term in the first pair of parentheses. there another x here, leading term in the next pair of parentheses. Okay, and so now the next step we're doing, it has to take some scratch work right here. Think about this final coefficient. This final, in this problem specifically, the final coefficient is also a constant. So 12 right here. We want to think of two factors including sign. Two factors including sign of 12. Okay, I want to repeat. We want to think about two factors including sign of 12 that goes into 12. That sum to minus 7. So minus 7 is the coefficient of the middle term. Okay, so we want to think of two factors including signs. But the next requirement here is that sum to minus 7. So two factors, first thing when I said two factors that including sign of 12 right here, it could be 1 and 12. Those are two factors, just fine. But will these two sum to minus 7? No, they won't. A next possible pair of factors, 2 and 6, including the sign. So positive 2, positive 6. Earlier I had positive 1, positive 12. Okay, do these two sum up to minus 7? Nope, they won't. Now, so on my board here, which is giving me more space, let's write down all the possible pairs. So including signs, we got 1 and 12, positive, positive. We can have negative 1, negative 12, negative, negative, but multiply together these two negative factors, multiply and getting me 12. But none of these pairs so far sum up to minus 7. So we can try 2 and 6. Okay, these are two factors of 12, and none of these, and positive, positive, but this pair once again does not meet that next requirement, summing up to 7. So we can have, how about minus 2, minus 6? Does that meet the requirement? Well, they are factors of 12 including signs, but they don't add up to negative 7. How about 3, 4? Positive 3, positive 4. Okay, these two are factors of 12 including signs, positive 3, positive 4, but they don't add up to negative 7. How about negative 3, negative 4? Okay, right, and that looks like the last one. So what I see now, this one here is the only pair. And believe me, once you're done with that, there can only be one pair that meets that requirement. So once again, the idea, we're looking for two factors, including sign, of the final constant, so that they add up to be negative 7. So minus 3 and minus 4, minus 3 and minus 4, adding these together, that gives me minus 7. And this is the reason why I choose this pair right here, this pair of factors. Okay, so what are we doing with this pair of factors? So now, allow me to just, instead of writing down all of those lists, so the list I've shown earlier, you can do that on scratch work, but formally speaking, the two factors are minus 3 and minus 4 that satisfy the requirement adding up to minus 7. Okay, so I can put minus 3 here and minus 4 there. The two factors, including the sign came along with that. So now I put minus 3 here, minus 4. So the way how it reads now, I have an x minus 3 in parentheses, in product with an x minus 4. That's one way of how you can write your factor form of this polynomial. So does the order here matter? Meaning, does it matter if I put the minus 4 here and minus 3 there? It does not matter. So you could have also done, so the same thing here, the same x squared minus 7x plus 12. You could have also written, with two pairs of parentheses, with an x here, with an x there. You can put a minus 4 here and x minus 3 there. Okay, these are all successful factor form of your polynomial, of your quadratic polynomial. And so now at this point right here, I've introduced this technique in the earlier lesson. So let's bring it in, even though it's not strictly required. You can always do this on scratch work right here. But so the work here has claimed that x squared minus 7x plus 12 can be written in factor product as the factor of x minus 3 times x minus 4. We can now easily multiply this out. FOIL. First, outside, inside, and last terms right here. We can quickly take some FOIL work right here. So x times x gives me x squared. X times minus 4 gives me minus 4x. The arrow here indicates. Minus 3 times x gives me minus 3x. And minus 3 times minus 4 gives me plus 12. And so now combining like terms on these right here, on these two terms right here, we're looking at the final quadratic x squared minus 7x plus 12. So we have landed, after foiling out, we have landed exactly into the beginning expression here. So now we know that we have done the correct factoring work. Okay, and so checking your work right here will always ensure that your calculation is done correctly. The reason we have to always check our work because sometimes these are a little bit tricky to find right here. And believe me, I've done these for years, so it takes me a little bit of time for anyone starting into learning about this. Be patient with your learning. Like I said, I've done some listing of all possible pairs earlier. You may have done that when you're beginning into learning this. And then as you building up your experience, it will get faster and it will keep getting faster. Okay, so that's how we are factoring a one variable quadratic with leading coefficient equals 1. All right, so now we're getting into those quadratics of one variable, but leading coefficient now other than 1. Okay, and now it's gonna get lengthy if I write down all the details I want, but specifically I want, so let's take a note of this. I want to lead you through learning about the case where in your quadratics all coefficients have GCF equals 1. So, or another way of saying the GCF of all coefficients equals 1. So we want to learn this specific case right here. Factoring a one variable quadratic with leading coefficient other than 1. But for learning right here, I believe the fundamental comes out from when we learn the case where all coefficients have greatest common factor equals 1. Okay. Another way of saying that they don't, when you see GCF equals 1, it really means people sometimes say they don't have a common factor other than 1. Okay, all of the coefficients don't have a common factor other than 1. All right, so let's get to it. All right, so here we are at that first problem under this category, a one variable quadratic, leading coefficient other than 1. The leading coefficient here is a -1, so it's other than 1. And I would like to refer to this as a special case that really deserves your attention. So I put that here, right here in our formal video lecture over here. So I want you to learn carefully with this special case when your leading coefficient is a -1. Okay, it's a negative, or more generally, you hopefully after going through the steps here, you will have some good understanding about what to do with generally a negative coefficient, a negative leading coefficient. Right now I'm using a -1 leading coefficient. So in this problem right here, see, a equals -1. That's why it's a is other than 1. All right. And then so now aside from the fact that the leading coefficient being -1, see, -1, 5, and -6. The greatest common factor, we have learned some how to find greatest common factor throughout earlier lessons right here. So you can quickly verify that greatest common factor throughout -1, 5, and -6 right here. Greatest common factor for all these three coefficients has to be just 1. And this is the detail I want to focus to right here. Okay, this is the details in the scenario. All right, so let's get to it. So for this quadratic polynomial, minus x squared plus 5x minus 6. So anytime right here we're having a -1 leading coefficient, but I would like to introduce the idea here is that anytime we're having a negative leading coefficient, it could be a -2 here, -5 here as well. let's factor out the negative 1 factor, making it, so really factoring out a negative 1. Now you've learned and so you can always look back at your video lessons about how you can find greatest common factor, but factoring out a negative 1 is entirely possible here. So think about this first term here has a negative 1 as your factor. So factoring it out, you have, see, think of that as, this is brain process. The minus x squared here is the same as negative 1 times x squared. And so now in that case, I would like to see the 5x right here as having a negative 5. So a negative 1, so it means minus a negative 1 times 5x. So, well, minus, subtracting a negative sign right here is going to be a plus. So it's the same with, if we cancel out the signs right here, it's going to become just plus 5x. But I purposely wrote the 5x term as minus a negative 1 factor times 5x. And then the minus 6 right here, again, I'm going to write it as a plus, and then negative 1 times 6. Okay, so now that's how I have displayed. And so this is just brain process. You don't have to exactly follow this way if you would like. If you don't like that, but the point now I want to point out is there's always been a negative 1 common factor. With that leading term being negative, you can always purposely see a negative 1 factor throughout all of your terms. So now recognizing the negative 1 factor, you can factor out that GCF right there. So that common factor now becomes negative 1 in front, and we've learned this technique back in our earlier lessons. So now the first term in the parentheses here becomes just x, positive sign, okay, and then minus 5x, and then plus 6, okay, and then a better way of writing it, minus, because the negative 1 times, we just simply write it as a minus outside of the parentheses, x squared minus 5x plus 6, okay? And so these are just brain process. You can easily just see that, hey, after we factor out, sometimes people also say that we factor out a negative sign. That works too. What matters is how you write that into the proper and the correct expression. So factoring out a negative 1 factor or factoring out a negative signs, all signs, think about the change here. In the beginning, before factoring out the negative 1 factor, all terms here, it was negative in the first term, positive in the middle term, negative in the last term. But now after factoring out, all of these terms here switch in signs. Okay, that's another way of explaining it. So you don't always have to follow this process if you feel this is too slow for you. It's just me. I would like to explain all of the deepest understanding. But in the end, if this works, just this quick shortcut works better for you, this is okay. But so now what? After we have factored out the minus sign, that's not the end of the story. We need to go even further. Have a closer look. Now, after isolating out that minus sign right here, our next task is to see this quadratic that's left over over here, that's the remaining quadratic inside of the parentheses here. Our task is to factor out that quadratic. Okay, so quick scratch work. The quadratic we are about to factor now is the x squared minus 5x plus 6. So this guy right here, we have learned that from the earlier part of this lesson right here, that it's a leading 1, okay, leading coefficient equals 1, right? It's a quadratic. So now it's just 2 pairs of parentheses, nothing easier than that. Put an x here, put an x there, okay? And then we're going to find 2 factors. We're going to find 2 factors of 6, including signs, that add up to minus 5. And so in my calculation, those 2 factors have to be minus 2 and minus 3. And again, for anyone who is beginning into this, don't hesitate about listing out a few possible ones. You can go with 6 can be broken down as 1 and 6, negative 1, negative 6, because it's positive 6 here. So those positive factors, including sign, could be these, right? Positive 1, positive 6, negative 1, negative 6, negative 2, negative 3, or positive 2, positive 3. What matters is we pick the one that's add up to be negative 5. Okay, so these are the 2 factors, including signs. So I'm going to put the minus 2 here, and I'm going to put the minus 3 there. Okay. And so I just want to emphasize the factoring work we have done here is for the quadratic polynomial, the quadratic expression inside of our parentheses is here. So now this is just part of the scratch work right here, but formally to carry on with this particular problem. Now, the minus sign remains the same, but the expression inside parentheses now gets factored into, that's the logic right there. See, we factor out the minus sign, and then we further factor out the quadratic that's left behind in parentheses. And what we have done here, according to the scratch work we've had, and it doesn't hurt to write down your scratch work as well. X minus 2 times x minus 3. This is our final factoring product right there. And this is the factor form of our beginning quadratic polynomial. All right. And so now let's quickly check, even though checking here is just should be done on the scratch work level over here, but we have minus, right? X minus 2 times x minus 3, right? And so we're gonna think about, we're gonna leave the minus sign out here. Let's do the foiling for these two factors here. So x with x with minus 3, minus 2 with x, minus 2 with minus 3. So we have, now be careful to use parentheses and then leave the minus signs here. So after foiling, we're going to have x squared minus 3x minus 2x plus 6. That's foiling. And then see, the negative sign here remains exactly the same like that. And now I'm going to combine like terms for those terms inside of my parentheses. I'm still leaving the negative sign here in parentheses. We're looking at x squared minus 5x after combining like terms on these two terms like that, and then plus 6. And now distributing that negative sign, we've learned that this skill from our previous courses. Distributing the negative sign, we're looking at now minus x squared plus 5x minus 6. This final polynomial over here, this final quadratic, lands exactly into that beginning polynomial, beginning quadratic that we were instructed to factor. So in that case right here, we knew that this was our correct factor form of this polynomial. All right, so here we are at another example. In this lecture, I call that example 3 right here, but we are instructed in this example to factor out this quadratic expression. Still, one variable quadratic expression. Leading coefficient a equals 2, not 1. Leading coefficient other than 1. And now quickly you can see that now disregarding all of these signs and all that, think about it. 2 and 11 and 14. The GCF for all of these has to be 1. Okay, and then you can quickly apply your skills that we've learned in the earlier lessons about how to find GCF on all three numbers right here to verify that, hey, 2 and 11 and 14, the greatest common factor has to be 1. And this is exactly that detail I would like to mention right there. Okay. All right, so now after I have clarified all of the details that this polynomial, this quadratic expression is falling in, then let's get to it. How do we factor a quadratic like this? A quadratic where leading coefficient is no longer equals 1. And then right now, the simpler, the detail we specifically want to focus to is all of these coefficients have GCF equals 1. So here's how I'm starting. Now, the first, this is A equals 2. This is B equals negative 11. And this is C equals 14. Okay. And so that's just a reminder about, how we name, how we label the coefficient with each term like that. But so now after clearly realizing the coefficients, my first step in doing this, my first step in factoring a polynomial, a quadratic expression like this, I am going to multiply A and C. So A is 2 and C is 14, the final constants, including signs. So all signs are included. So positive 2 times positive 14 in this case. So that's the first step. So that means we got 2 times 14. That will give me 28. So that's the first step. And because of this first step right here, many textbooks, including the one you are using, the authors there consider this as what they call the AC method, the AC method right here. The AC method, because you multiply the A and the C together. Okay, I personally don't name the method like that, but you know, the way I work is exactly the same with how many textbook authors refer to that as the AC method. Okay, so something for you to know. So anyway, we multiply the leading coefficient with the last constant. So you have that number right here, 28, because 2 times 14, 28. Okay. The next step now, similar to what you have learned back in the earlier part of this lesson. Think about with 28 now. I want to think of two factors. I want to think of two factors, including signs again. I want to think of two factors, including signs. So the technique you have learned from example 1 now can carry in. But we take that method into the final coefficient here where it's A times C. It's not simply just the last coefficient. So with 28 right here that came out from A times C, we find two factors, including signs, that add up to, that sums to minus 11, the middle coefficient. The middle coefficient. All right. And so in my quick calculation, I can find that it's going to be minus 4 and minus 7. See? Those two coefficients, or those two factors, including signs of 28, or minus 4 and minus 7. Those two factors right here will add up to be minus 11. That's what we're looking for. So once again, after multiplying A and C to get 28 in this problem, or generally after multiplying A and C, we want to look for two factors of that final product right here, including the signs included, so that their sum add up to the middle coefficient. Okay, and you can go ahead, you can always rewind the video here to keep hearing my information, my instruction again. In case you are nervous about how I can calculate those so quickly, it's okay. I've done that. I've done this for years right here. But when you're a starter, again, 28 is your numbers, right? We want to find, the goal is to find two factors, including signs. So there can be a lot. There can be positive 1 times positive 28. There can be negative 1 and negative 28. There can be 2 and 14. There can be minus 2 and minus 14. Okay, so we just need to list down all of the possible pairs of factors with signs included, and then we look for the 1. So there are going to be many more involved, but you will eventually land into minus 4 and minus 7. This will be the only pair that meets our requirements. The sum here adds to negative 11. The sum here will add to negative 11. So minus 4 plus minus 7, that gives me negative 11. The coefficient at the middle term. That's how you can do that on scratch work right there. Okay, I don't expect anyone learning from this lesson to be quick at that. It took me years to get that. So you'll be experiencing the same thing right here. But that's how we're learning. Okay. And so now that we have found two factors, including signs, two factors of 28 with signs included, that sum to the middle coefficient, negative 11. So what's the next step? Now, at this next step right here, allow me to present that. The way I present it now may be slightly different with how you're learning that, how you're seeing that being presented in the whatever textbook that you're using. But I found it more effective that we construct a little square. Okay, we construct a square. The square here, we're gonna split that into 4 sub-squares right here. Okay, so we draw a square and we split that into 4 sub-squares right here. The top left corner right here. The top left corner, I'm always gonna put the first term, and I'm talking about the full term. So it's 2x squared. Always, first term always go into the top left corner of our squares. Okay. These two that you have found from the previous steps, you're gonna put it in, then you're gonna put it in along the diagonal entries. This entry right here, this diagonal entries, not that one. Okay. This one here, this last entry is called the bottom right corner. We want to leave it blank. So aside from these two that we already filled out, we don't want to do anything with that bottom right corner. So that's the remaining diagonal entry that I was talking about. So you can put the negative 7 here, and put the negative 4 here, or you can put the negative 4 here and this negative 7 here. It does not matter. It's your choice. Yeah. Okay. You put the two numbers that you have found from the previous steps right there. All right. And now, but you're not simply just putting in the two numbers. You make sure you put in the two numbers along with the x, the variable that's involved. So now here's really indeed you're putting in minus 7x and minus 4x in that corner. All right. And so now, and we're still leaving this square here blank. We don't really need to fill in anything for that for the rest of the problem. But now think of it like this. You can either go by the row or by the column. Your choice. Okay? For now, for this lesson, I go by the row right here. On that row right here. These two entries. Let's find the GCF. Admittedly, there's a negative sign here, but you see, since the higher term, the leading term here, because that one here comes out from the leading term of our coefficient, so the leading term being positive. So let's look for just positive expression of our GCF. So the only GCF we can find among these two terms is simply just x. So I'm going to write that x out here. So once again, x came out as a GCF of these two terms. As a quick review, see? 2x, prime factors are 2 times x squared, okay? Minus 7x, prime factors are negative 1 times 7 times x. So the only common factor is here, the x, and the x we choose. So the GCF is just x right here, the least power, the lowest power among the two parties here, okay? And that's how I chose that GCF, and I put it here. See, and these two are laid down in a row, so I put that right in the beginning of our row, at the leading part of our row. Okay, so now that once you have put the GCF of the row, okay, here's the thing. Think of this, the whole purpose of this square here is think of that as a multiplication table. So let's look for what factor multiplied with x. What factor, right now unknown, but think about it. What factor multiplied with x will give you 2x squared? What factor, again, I repeat, what factor, think about the factor that multiplied with x will give you 2x squared. That factor has to be, needless to say, 2x. Because as a multiplication table, as I said, rows multiplied with columns, that gives us the intersection entry right here. So 2x multiplying with x must give you 2x squared. And then just a little bit of additional comment right here. In case you chose to find the GCF of these two terms in the vertical column, then the GCF will also be the GCF of these two terms that's laid down in the column right here will also come out being 2x. Okay? So we only need to find a GCF for either one row or one column. And then you should be able to easily find the other one by thinking of that as a multiplication table. So I found this one here, and then so now think about 2x. It has to be 2x, so that's 2x times x will give us 2x squared. All right. And so now again, think of this table as a multiplication table. What factor multiplying with x to give you minus 7x? What factor should I multiply with x to give you negative 7x? That other factor has to be minus 7. Because minus 7 times x will give me minus 7x right here. And then again, for this entry, think about what factor multiplying with 2x will give me minus 4x. And that other factor has to be minus 2. Because minus 2 times 2x will give you a final product of minus 4x. All right, so we have completed the squares here, but the result here will be tremendous. You will be shocked. Ladies and gentlemen, 2x minus 7. From this part of the square that we have found, we can put that here as one factor. Okay, and then there's another pair of parentheses. X minus 2. X minus 2. goes in there. All right, so that's how we put that into the factor form. So now in the end, final conclusion, our beginning quadratic 2x squared minus 11x plus 14 really can be factored into 2x minus 7 times x minus 2. And this is the final answer to that. All right. And so now you can always double check by, we have done this quite often, so I don't need to put it here right here into our video lessons. That's just waste your time viewing it, but you can always FOIL out again to ensure that after foiling it will land into this particular expression. I could have done something wrong in my calculation right there. So foiling it out to make sure to check that, make sure that it's going to land into the beginning polynomial with the beginning quadratic will be your best way right there. But if I did my work all correctly, the foiling work should come back exactly the same with the 2x squared minus 11 plus 14 right there. Okay. All right, so just summarizing the steps here for this kind of problem right here, and this is a big method right here. So it's a one variable quadratic with leading coefficient other than 1, and coefficients, all coefficients have greatest common factor equal 1. So the first step is to multiply a and c. The first step is to multiply a and c. That's why I got a times c, 2 times 14 equals 28. After that, I'm going to find two factors of 28, two factors that go into 28, including signs, that sum up to the middle coefficient. That's why I chose, and that's why I found, right? And minus 4 and minus 7 is the only pair. That's why I found minus 4 and minus 7. After I found that pair of factors, I'm going to draw a little square here. And this is the technique that I learned through my experience, but maybe a little different. The way how I present that may be a little different with how you have seen that in your textbook like that. But anyway, so you put the two numbers there. The order doesn't matter. Okay, so I put the minus 7, but now make sure you include the x, and the minus 4 here, make sure you include the x. Okay, and so I have 2x squared minus 7x on the row, and then I have 2x squared minus 4x on the column. And so that's why we can make choice. We can go by those terms on the row here or those terms on the column. So I chose, for this problem right here, I chose to look at the GCF, for those terms on the row right here. If you chose to do, if you would like to work to restart the problem with the square right here and choosing the two terms on the column right here, we again find the GCF. But we only need to do that either for the row or for the column. That's the start. We only need to do one. We don't have to do both. Okay? But now, in the way how I did that, once I chose the GCF on this row right here, that came out being x. Think of this as a multiplication table. So x being the GCF of these two terms. So now for that entry being 2x squared, think about it must be 2x multiplying with x to give me 2x squared in this entry as a multiplication table. And so now with the x that I have found right here, with the x that we found right here, think about for this entry, it has to be negative 7 being the other factor multiplying with x to give me the product negative 7x. And then now think about the minus 4x right here. I put the 2x here already. Okay, so minus the 2x, the other factor has to be minus 2, so that minus 2 times 2x giving me minus 4x. And so that's how I laid down these entries outside of my table. But now these entries are coming together will become our final product. And then finally writing it all down, our beginning quadratic expression right here is written in factor form, 2x minus 7 times or in product with x minus 2. All right, so now it's time to get into that final form of a quadratic, a two-variable quadratic. So believe me, everything you have done in terms of how we can factor a one-variable quadratic can be utilized directly into this kind. So we only need to add one additional step. So when we are factoring a two-variable quadratic, we just need to add in one additional step before doing the usual one variable quadratic. So now let me demonstrate the idea in one particular problem. So let's now call that example 4. All right, so in this example right here, I call that example 4. We are instructed to factor out this quadratic 6x squared plus 7xy minus 5y squared. So this is that quadratic where I call that it's a 2 variable quadratic right here, and whichever the leading coefficient, doesn't matter, we got. So you can see this as the leading coefficient, you can see the other one as the leading coefficient, pretty much doesn't matter. So all I see it's a 2 variable quadratic. All right, so the trick into doing this, the important steps before you do anything else, the important steps when you're handling a 2 variable quadratic, think about the first step right here. Think about we ignore one variable. Just think about we ignore one variable. And so by ignoring one variable, let's rewrite. So in what I argue right here, we are ignoring one variable, even though there are 2, but we're ignoring one variable. So let's rewrite the quadratic as a 1 variable by ignoring the other variable. So, and which one is the variable that we ignore? Your choice, really your choice. How about it's just me, I commonly work with the x, so let's ignore y. So I'm going to ignore the variable. So in this problem right here, I ignore y. But you could have also done the same by ignoring the x. So ignoring the y variable, here's how we can rewrite the polynomial, the quadratic without the y variable. It's going to be 6x squared, because the first term didn't have any y anyway. So ignoring that makes no difference. Ignoring the y variable makes no difference. Plus, now instead of 7xy, like I said, we ignore. Think about we purposely ignore. So now it's going to be 7x. Like I said, we just ignore. Think about the equivalence version. Think about the equivalent. It's another way of explaining it. An equivalence version of the quadratic without the second variable. Okay. So the middle term now, the corresponding form is 7x plus 7x. The last term here will be minus 5 because we ignore the variable y. So it comes out just constant. So now after ignoring one variable right there, okay, the corresponding version will become just 6x squared plus 7x minus 5. Now we bring ourselves into those forms that we are familiar with. This form here is, yes, is one variable quadratic. Leading coefficient is now here. Leading coefficient is now here, other than 1. Okay, and so A, C method is going to kick in. So I'm going to multiply A times C, okay, and that gives me 6 times negative 5. That makes it minus 30. Okay, and so now minus 30. I'm repeating that process we have learned back in the earlier example. Okay, I'm going to find the 2 factors, including signs, of minus 30. The 2 factors of minus 30 that sum to 7, positive 7. Okay, so those 2 factors are 10 and minus 3. All right, 10 and minus 3. And again, feel free to put it on Scratchwork and list down a whole bunch of pairs of factors, including signs that eventually you're gonna find the only one pair. It's gonna be 10 and minus 3. So 10 and minus 3 are factors, including signs, of minus 30 that add up to be positive 7. Okay, so now after we've found those, I'm gonna construct that little square here. All right, there's my square. The leading term again, because right now we are entirely working as a 1 variable quadratic with leading coefficient other than 1. So I'm going to use that. I'm using the AC method right here, and it's the second the time that you're seeing that within this video lesson of how I construct through this the square right here. So the upper left corner, I'm going to put in 6x squared. The 2 numbers I found right here, I can put them anywhere on this diagonal. The lines here, anywhere on the 2 diagonal entries here. So let's put the minus 3 here, okay, and the 10 here, and let's put the x there with that. So minus 3x and 10x. It's just my choice. I could also put 10x here and minus 3x here, okay. So in my earlier example in the problem where I demonstrated how to do this method, I used with the row, but to clarify, in case anyone missed out, I can also do the vertical terms, the two column terms here. So among the two column terms, my GCF, let's do a quick calculation. So now for the column terms, one term is a 6x squared. In prime factors, it's 2 times 3 times x times x. Okay. Or we can see that as x squared. So 2 times 3 times x squared. The other term is 10x. You can see that as a 2 times 5 times x. Okay, so these are the prime factors. So that's common, right? Lowest power is 1. That's also common. Lowest power is 1. So GCF will come out being 2x. Okay. And so now the two terms I found here, the two terms that I have focused to were, and again, as I explained earlier, it's just simply a choice. So I chose these two terms, they line up in a column. So now the GCF here is going to be, that we found being 2x, I'm going to have to put that on top of that column. So 2x being put right here. And we have to do that for only either one column or one row. And I already chose it to do that. Doing that with the column right here. So we're done with that part. Finding the GCF on the two terms, either on the column or on the row. Okay. And so now think about this square as a multiplication table. And we already had 2x here. So think about for this entry being 6x squared. I need a factor that multiply with 2x. That gives me 6x squared. So that other factor unknown right here has to be 3x. Because 3x multiplied with 2x give me that entry right here being 6x squared. All right. And then the same way right here. With 2x found right here, I need a factor so that multiplying with 2x will give me 10x. So that other factor has to be positive 5. Positive 5. For good purpose, let's write it down positive 5, the positive sign right there. And then now for 3x, think of that minus 3x. I mean, think of that multiplication table. So I need a factor that multiply with positive 3x here that will give me minus 3x. So that other factor has to be negative 1. All right. And so all of a sudden I can see that, hey, it looks like 3x plus 5 as one pair that stays in one pair of parentheses, and then 2x minus 1 stays in another pair of parentheses. Okay. And so now that means our quadratic with the second variable being ignored, 6x squared plus 7x minus 5 right here can be factored into 3x plus 5. Okay, I purposely left some good amount of space right here. Times in product with 2x minus 1. So that's our that's the factor form of our quadratic expression, ignoring the other variable. But now what's the original? How do we get to the original one? The original quadratic is the 6x squared plus 7xy minus 5y squared. So here's the factor form. There's a 3x plus 5, just like how we've done that with the earlier one. 3x plus 5, but now after reintroducing, bringing back that ignore variable, the y and the y here, then now it's going to be 3x plus 5, 3x plus 5, 5y here. And then here we have in products with 2x minus 1, so it's going to be really 1y right here. So in the end, our final product, 3x plus 5y times 2x minus y. That's our factor form, and that's how we factor a quadratic with two variables. The fundamental step is to ignore one of the two variables right there, and then work it out just like all of the techniques, bringing in all of the techniques you have learned in factoring a one variable, okay, one variable quadratic, and then in the end just bring back that original variable that we ignored. and then that's how we factored it. Okay, and then now we can easily FOIL this out. Again, checking your work right here, you can easily FOILing this out, and then that should, if I did my work all correctly, you should arrive exactly at 6x squared plus 7xy minus 5y squared. All right, so I want to introduce for anyone who is learning in this lesson about those quadratic expressions that are irreducible. So irreducible really just basically another name for another way of saying that's not factorable. So irreducible means not factorable, but what does factorable mean? Factorable means a quadratic expression can be put into factor form. So those we have been able to do in the earlier part of the lesson, those are all the factorable quadratic expressions. But now the reason for this short lesson here is that there are quadratic expressions out there that are irreducible. Or in other words, there are quadratic expressions out there that are impossible to factor, to put into factor product based on the real numbers. So allow me to introduce a few, and I'm going to, along with this short lesson right here, I am going to introduce a quick criteria of how we can determine, a quick solid technique, how you can determine whether a quadratic expression can be irreducible or not. All right. So let me bring in the following illustration. All right. So what we have here is a quadratic expression. It looks just like any of those other ones that we have learned throughout our earlier part of the lessons. However, if we look a little closer into this one right here, if we attempt, and by the way, as far as classifying the quadratic expression that we're currently having here, this quadratic expression is a one variable quadratic expression, and it has a leading coefficient other than 1. And so we've learned the AC methods, or any method that you've learned. Let's bring it in and see. And so the most familiar, the most common method is the AC method. So I'm going to multiply 4 with 5, and that gets me 20. And then just as usual, from what we've learned, we're looking for some two factors of 20, including signs, that add up, that sum to positive 1. But this is where I don't want to waste your time watching, but you can pause the video right now and look for a pair. Look for a pair that satisfies the set condition. We want to find a pair that's the sum up to 20 and add up into a pair of factors that including sign of factors of 20 and add up to positive 1. So think about it. I can try a few. Minus 4, minus 5. Those are factors of 20, but that doesn't work. 4 and 5, those are factors of 20. That pair doesn't work. And you can pause the video and keep searching for more. And so now the idea is, and that's where it starts feeling a little, it rings a bell about whether we can actually indeed factor this quadratic. And so now you can go ahead and give it a few more tries here, and I can guarantee you, no matter how many more pairs of factors you can find out of 20 right here, you won't find a pair that sum to positive 1 as the middle coefficient here. Okay, and so it started ringing in our mind that, hey, maybe this is a quadratic expression that is not factorable or that is irreducible. And so, but the idea now is that we definitely don't want to always search hopelessly for these pairs of factors, and then to prove that it fails, we fail finding one pair that satisfied, that worked with the AC method. And so in this way, allow me to introduce a lot more clear-cut technique right here, a lot more solid technique. So the aim here is to show that we've done a few attempts. And now the aim here, I would like to show that this quadratic expression here is irreducible. That's formally to put it in as the instruction of the problem right here. And so this quadratic expression, we've learned about what a quadratic expression is. Then a here, the coefficient that goes with the x squared term is positive 4. B is positive 1. That's right from the middle term right here. And C is the positive 5. And in our problem here being a one variable the quadratic expression, then our c here is simply a constant term. So we got a, b, and c. Now, the truth behind the scene now is that we are going to calculate a quantity that's called b squared minus 4ac. So after calculating down what a and b and c is from your quadratic expression, we are going to calculate. So this is a testing criteria right here. This is the way we test whether our quadratic here being reducible or not. So b squared minus 4ac. This is what we're about to calculate. So b equals 1. So b squared here, now we're just simply substituting these values. So positive 1 all squared minus 4 times 4. This is the value for a. This 4 is part of the formula, and then times c being positive 5 in our case here. So this b squared minus 4ac expression, applying that to our particular quadratic expression here, we come out to the following final value right here. It's 1 minus, now that's 80. So we have 1 minus 80, negative 79. Allow me to put that negative sign in red ink right here. So the point now is that what we realize is the b squared minus 4ac turns out to be a negative value. Negative 79 is a negative value, less than 0. And so that is solid enough. That leads to the conclusion. The conclusion here says, as a conclusion, for x squared plus x plus 5, this quadratic expression here has no factor form. And that's how we can detect, that's how we can tell whether some polynomial, some quadratic expression can indeed be irreducible. That's a formal term, but in a more in a more friendly term right here, some term that everybody is more familiar with, it's not factorable, or the quadratic cannot be put into factor form. And so in that way, allow me to bring in another example. And continuing from the earlier examples of the same lesson here, let's call that example 5 here. All right, so what we have here in this example, we want to show that this given quadratic expression is an irreducible quadratic expression. And so again, I remind that earlier I was saying irreducible means we cannot put this quadratic expression into factor form, or it has no factor form, or a different way of saying it, it's not factorable. Okay, so the only secret is simply write on that b squared minus 4ac. So we got to nail down what a is, what b is, and what c is right from your quadratic expression. So 4x squared plus 1. Now in this one here, this quadratic expression here, we don't see the middle term, the x term. It means 4x squared plus 0 times x plus 1. So in that way, easily we can recognize that a equals 4, our leading coefficient, or our coefficient for the square term. And then the b term is 0. That's where the 0 comes from. And then the c term is a constant, being 1. And so now once we have identified what a is, what b is, and what c is, we can go ahead and fire up simply just that. Fire up to calculate the b squared minus 4ac. And now in this case right here, b squared is a 0 all squared minus 4, part of the formula. A is 4 times 1. Right? That's how I have substituted the values in. And so a quick calculation comes out being minus 16. And so this is clearly the value of our b squared minus 4ac from this polynomial, from this quadratic expression, is clearly or apparently less than 0. And that leads to a conclusion. So now as a conclusion, this polynomial, this quadratic expression 4x squared plus 1 has no factor form.